All right, guys, so good evening. So we are going to now continue from where we left off in sets. We were looking previously at Venn diagrams, and we were looking at how to identify the different subsets within the Venn diagram based on the different regions. And so even though we may have the rectangle that represents the universal set, we know that we have sets that are represented with circles, and we know that there are regions of overlapping with circles, and we know that things can be inside circles, some things can be outside circle. So even those regions that are outside are overlapping, those are also subsets, are smaller sets. And so you have to consider those regions as sets, all right? So when you're using your set notation, you should be able to assign the appropriate symbol based on what you're trying to find. So you should by now know what intersection is, what union is, what complement is, and so forth. Now, so we are now going to be looking at intersection and union. And so we are going to now put elements within Venn diagrams. So we'll be looking at elements which are listed and how these elements can be represented using Venn diagrams. All right. So we want to start off looking at problems with intersections and union. So intersection of two sets. Now consider the set A and B. The set of elements which are common to both A and B is the set belonging to the intersection, written as A with that symbol looking like an N. So that is intersection. So A intersect B to means the word A intersects B. All right, now this is what the diagram looks like, and the region shaded in purple is what denotes the region of your intersection. So wherever two sets are overlapping and you have common elements in that area, those common elements would be members of the intersection, and those elements represent elements that belong to both sets. All right, so in this situation where you have an overlapping of two sets, then the purple region is the intersection. Now, if we are to look in terms of what is listed here, the question is, the example is, if A is a set, if A is a set, are the set of elements 1, 3, 5, 7, 9, and B is a set of elements 7, 9, 11, you have to find the intersection. Now, so in this case, you can find the intersection by looking at the listing. The intersection, the elements of the intersection would be just those common elements in both sets. Now, we can identify them in the listing, and so we can also represent them in a Venn diagram. So here, in terms of what is common to both sets A and B in terms of listing, what are the elements that are common? Anybody? Miss Green?
9, sir.
All right, so 9 would be one of them.
And 7.
9 is in set A and set B. And so we say those are common. And so those are members of the intersection.
What about 7?
So we have 9, and as well we have 7. Now, so these are the common elements in both sets. So they belong to the intersection. So if we are going to write the set in terms of the listing, then we could write A intersect B is equal to so that will be equal to the set of elements 7 and 9. All right, so that's how we would list the members of the intersection. But suppose we are asked to represent this on a Venn diagram. So clearly, to represent it on a Venn diagram, we would actually have the set A represented with a circle and the set B represented with a circle. And because there is a common, because there are common elements, that's an indication that there is a region where you have the two sets overlapping. So if you look at two listing, or two sets, and you look at the listing of the members, once you have members that are common to both sets, it means that your Venn diagram, you draw the circle so that they overlap. And the region where it's overlap, that's where the common elements going to go. Now, suppose there are no common elements in the two sets. What do you think you would do when you draw the Venn diagram?
Draw them separate.
So you would have to draw the circles separate and apart, meaning that you don't have any overlapping region. All right. Now, generally, your Venn diagram, your circles are encapsulated by a rectangle. Now, for the sake of simplicity, I just have these circles without the rectangle. All right. So here now, A intersect B is equal to 7 and 9. Now, looking at this one, how would you draw this Venn diagram? Do you, what would be the answer for A intersect B here? Is there any common members in A and B? That
No, sir.
no. If there are no common members in A and B, what A and B would be? What would be the answer?
Empty set.
Yeah, it would be an empty set. So you would have to say the intersection of A and B is equal to null or empty set. So there are no common elements. The two sets are disjoint. So disjoint means that you're drawing the circle separate and apart. And so set A have no overlapping with set B because there are no common elements in A that are also common in B. So they don't have anything in common, so you draw them separate and apart, and so their intersection is the null set. All right? So if A and B are disjoint, A intersect B equal to null, where everybody should know what the symbol for null is. All right, any question? All right, so that should be clear so far. Let me see the hand of those who are clear on what is just explained. All right, so only 2 persons? Okay.
What was that, sir?
So what we have done so far, are you clear on what was explained? Are you clear?
I think so.
Okay. All right, so let's hope. We'll find out as we go along. All right, here now we talk about intersection. Now we're going to talk about union of sets. Now, union if you think about union, you can think about uniting the two sets together. When you unite two sets, there is somewhat putting everybody together as one big happy family, right? Just like when you have family reunion, or everybody, every set of members in the individual families come together as that big reunion set where everybody meets each other and refresh their memories of who they know in terms of the family. So you can think of the union as uniting the sets. All right, so all the elements in A together with all the elements in B is a set of elements that form the union of a set of A and B. And it is written as A with the symbol looking like U. So you shouldn't miss that symbol, because union starts with a U. The symbol looks like a U. So you should know what symbol is appropriate to use when you're referring to union. So A, union, B, or A with the same symbol looking like a U means A, union, B. Now here we have R is a set, sorry, if S is a set 1, 3, 5, 7, and R is the set 7, 9, 11, S union R, what would that look like? Now, so my question though, how would you draw the Venn diagram for this? First and foremost, what would be the members listed in the union? Can somebody tell me what members you get from the union?
You'd have 1, 3, 5, 7, 9, 11.
So S union R is equal to 1. So it is a set of 1, 3, 5, 7,
7, 9, 11.
9, 11. Now, what you notice here, even though the 7 occurs in both sets, in the union, we only count it once, right? Because it's the same 7 that is in the R, which is that clear, guys? So that's what you would get for the listing. Now, how would you draw this Venn diagram to represent the information? Ms. Trabia, walk me through the drawing of the Venn diagram. So first, let us start off with our
box.
rectangle. And so next, we must have our circles. What I must do next, Ms. Trabia? How must I draw these circles? What is there?
Sir, is it that the other circle will go over that one?
Is it that you're asking me or you're telling me?
I'm guessing, sir.
You're guessing? Why is it that you're guessing, Ms. Trabia? Aren't you listening to me all along?
It wouldn't be disjoint and intersection.
If it is not disjoint, then it must be overlapping, right?
Yes, sir.
Right, so once you have a common element, it means that the two circles are overlapping, and so you draw them over. And so once you have drawn it like that, what next should we do now in terms of putting in the members in the Venn diagram?
We would have S, which would be on my left. We would put 1.
So we'll label this one S. Let me label them with the correct color. So label this one S. And then label the other one
R.
R. And now,
In, okay.
go ahead.
In S, I would put 1, 3. The odds, yeah, right there. 1, 3, 5.
3,
5.
5. All right. What else?
Then in R7, no, 9 and 11. 9 and 11.
9 and 11. Yeah, try clearing, miss.
Not in the
said
intersection part, in
We
the
cover
bottom
those
part.
region. And you were here the last class, Miss Trevor?
Sir?
Were you here the last class?
Yes, sir, I was late.
Oh, but you remember how to specify the various regions though.
R only, sir. In R only,
All right, so in R only, you would put what?
11 and 9.
All right, so you put 9 and 11 in R only. All right, remember you separate your numbers with commas so as to prevent confusion.
Okay.
I am not so used to writing with this thing, so to get it, you have to bear with me. All right, what else now, miss?
In the intersection area, we would have 7.
All right. Okay, anybody else agree with Miss Travia's diagram? Is there anything missing from the diagram?
No, sir.
You should label your universal set U. All right. So that's it. Because you have to label each set, you're really saying what the name of the set is. So the circles, you label them in accordance to what letter represent them. For the rectangle, you label it with U because it is a universal set. All right, anybody else? Let me see the hands up, those who are comfortable with this diagram and they are in agreement with the diagram. All right, so person seem to be in agreement. Let me see the hands up if you are not sure about the diagram, or you are not sure if you should agree.
Sorry, can you do another one?
Ms. Clark, what is you're not sure about this diagram?
Sir, it just looked like it looks like I'm not sure. It's
All
not
right.
showing where it is saying union.
So the idea then, if you look in the listing, right, you would see that you have for the set S, you would have what? 1, 3, 5, and 7. In R, you would have 7, 9, and 11. The fact that you have a common element in both sets, it means that there are elements intersecting. So that is a cue, or that's an indication that the two sets have to be overlapped. Now, even though you draw it indicating the intersection, it doesn't mean that it nullifies the union, because the union is just taking all the members in both sets together. You follow?
Yes, sir.
Right. So even though it is drawn overlapping, you're just accounting for the members that are common to both sets. So you have to draw it showing that overlapping region for those members, because it's not a disjoint set. It can only be disjoint when you don't have any common members. You follow? And for this joint set, you would draw the circles separate and apart.
Yes, sir.
Is that clear?
Yes, sir.
All right, good. Is everybody clear about this? Let me see the hands. Is there anybody else still not clear? Let me see your hand. All right, going once, going twice. All right, so we're moving on. So here we would have the set drawn in this way, and the union is simply listing all the members together. And notice that we don't list the 7 twice, even though it occurs in each set once. Because the 7 which is in S is the same 7 which is in R. So it just means that 7 is a member who belong to both sets. And you can think about it in this way. When you used to attend probably high school, some of you would have gotten involved in clubs. And if you are in a club, say Red Cross, it doesn't mean that you can't be in 4-H. But there might be some members in Red Cross who are not interested in being in 4-H. And so those members would be in Red Cross only, right? You may have some members in 4-H who are not interested in being in Red Cross. So those are in 4-H only. But you may have members in both Red Cross and 4-H, persons who decide that they want to be a part of both clubs. Then those members would go in the region